you don't mind.
Nice event. Hard event. Did you actually look at the rules? Anybody, did you look at the rules? They're pretty tough. One thing I'm take issue with, okay? And I'm going to try and get this changed because I was hoping Dr. Putz would be here. Several years back, when there was so much content in one of the areas, like it was either planets or stars, we only had one page of notes front and back. Well, at that time, I was doing a workshop in Phoenix with the Summer Institute, and I went over this and I said, they can't do that. You need at least 2 double-sided pages. And I've been working on my mind ever since I got the rules and started reading it. I says, there's a lot of content here. How are the 6th and 7th grade students going to learn this stuff? Fortunately, I can point you out to a lot of resources. And what I like to provide you with is resources. I'm not a great one for lecturing on content. I use examples or something, but I'm not going to lecture to you because I'm not a good lecturer, and I don't like that. You're probably as knowledgeable as I am. But my experiences let me know how to have you approach your students and how to coach them without taking a lot of extra of your time. Remember, Science Olympiad is for the kids, not for you. They're to do the research, not you. This woman wrote a note to Dr. Putz and was really angry. She said, how in the world do you expect me to look all this stuff up and give it to the kids? The answer is you don't. It's the kids, because you get excited kids. You provide them with resources. So I'm going to give you some resources today. You can use those resources. Some of them I do commercially. I don't make a lot of money. My wife gets mad at me because I don't make any money on my company, but that's not my reason for being there. I love providing materials for coaches so that they can use it with their kids. Kids get excited, okay? And so that's one of my primary things I want to do. And I've got one activity called Star Clues. This is an introductory type of an activity. I'm going to share this. I feel more secure with my use of this particular computer. I've got a bunch of cards on here, but I'm going to give a key chart. Here's a student chart. See how long it takes to get up there. Okay. Maybe I can get it down just a little bit so you can see it. I'm not going to do this with you, but I'm going to share this with you. Okay. No matter what you do with this event, you're going to have to teach the basics, or you give them opportunities to learn the basics. The basics are, what's an HR diagram? What does it do for me? What's the difference between a first magnitude star and a minus 15 magnitude star or minus 20 magnitude star? Those basic things you need to know. Pictures. We only see visible light. When you see pictures from the Chandra X-ray Observatory, which I'm an agent for, I was supposed to change my shirt. All right, I don't want to do that in public. I'll show you what it looks like because I'm proud of it. I was an agent for the Chandra's spacecraft. This is my shirt, see? It's kind of warm, but I made lots of presentations. I was a resource agent, but they do away with you after 10 years. No, not with you, they just do away with their construction. Maybe they do away with me too, but anyway, I was an agent for them, so I was fortunate to have been this way for about 10 years, so I learned an awful lot. I read through the rules and I said, my gosh, I'm glad I was a resource agent. How would I learn all this stuff in time to make a presentation for people? This is an activity, and you're going to get this. Everything that I'm talking to you about is going to be on the Ohio Coaching Clinic website. Everyone. Some of them might be on there because I gave them a lot of stuff. You know, I'm just going to give you basic what's available. But start with the basics. Don't start with type 2 supernova, blow up stars. Don't start there. Start basic, okay? And that's what I'm hoping you can do. If I can find this, I've got clues. And there's little cards like this. I made this in 2004, but it's still apropos for this one. But I'll ask a question. It can be in any order. You print them out on little cards, cut them out, and the kids go through them. They can stack up cards. They read a clue. Antares is the coolest and only star of its spectral type included on this chart. So do I have enough clues to fill this in? Maybe not. Maybe you will. If a clue fits, let it go. If it doesn't, put it on your old stack and keep going. Next clue might be Deneb's absolute magnitude is 2 magnitudes brighter than that of Antares and 4 magnitudes brighter than that of Spica. Okay, they can look through it and they can fill this chart out. 6th grade kids could do it because that's what I taught basically. So it's not hard. but it gives them a working activity. If you just sit down and read something, you can read it without giving it much thought. Like when you're really tired and you continue reading, you say, why did I read the last 2 pages? So you put it away because you realize it's time for bed, okay? But start out with the basics, and this is just one of those activities. There's quite a number of cards. When you get done, this chart will be filled out, and I even gave an answer key. It's all on there. It's a really good activity called Star Clues. It's one of those you can kind of start out with. I also have a set of cards for you. And each person gets a set of these. No longer published. They're on the web. They're on the web, but you got to print your own. So I'm giving you a set. And this one, they've got one called Cosmic Connection, and they got this one that's called Stellar Cycles. You get a series of cards like this. They're really beautiful pictures, and you make the different sequences. You arrange the cards in different sequence. One for a standard star like our own, and it's like from the stellar nursery all the way to it's becoming a white dwarf and casting off its nebula. It's that's what's going to happen to our star. There's basically 3. When a star dies, it will die mild, like our star. It will die mild and it will cast off the outer layers of the Earth. We won't see that, but it would do that. Then they got another one that are gigantic stars. And the larger the star, the more mass a star has, the more furiously it burns its fuel. When it burns its fuels and it's out, it goes kaboom! It's really kind of cool when this happens, and there's an experiment you could do. You'll love it. You take a large classroom ball. I didn't want to travel with it, okay? Take a just rubber ball and a little ball on top of it. You hold the little ball and drop them all at the same time, and what you'll see, when it drops on the bottom, it deflates and it goes kabang! That's exactly what a star does. It explodes. It runs out of its last fuel, and it makes iron. Iron is the end of the cycle for a star. And the first thing a star will do is collapse. It goes kaboom. That's a type 2 supernova. And then there's another one. Like our sun, we know it will become a white dwarf eventually. But say there's a 2-star system, and they started out at the same time. They had different masses. So one star became a white dwarf before the other one, and the other one's still in the red giant stage. This little Hummer has lots of energy to draw, lots of gravity to draw some of the material from that supergiant star. It's going to draw this material, and it's going to reach a level called the Chandrasekhar, which Chandra's spacecraft was named after. It's called the mass limit. Once it hits about 1.4, that star will blow itself up because it can't have that much. And this Indian astronomer was the guy, Chandrasekhar. I can't pronounce his first name. I have a hard time with his last name. He was the one that discovered it was 1.4 mass, Earth masses, solar masses, that caused that star to explode. But that's what happens to that one. That's basically the 3. Then you've got the little red dwarfs will burn forever and ever and ever and ever, and then a little bit more, few more evers, and eventually it will turn into a little white dwarf. But anyway, there's basic things. Then there are some stars that are so massive, that when they use the last of the energy, they go kaboom, and they become a white black hole instantaneously. Okay? So you got a white dwarf, a neutron star, which is like a big star, but not the gigantic one, and the black holes. We know there's black holes. Nobody's ever going to discuss this existence. We know they exist. We've done it, by the way. I want to talk about that too. When you see these, and I started out, but let me get my thoughts together here. When you see photos and you say it's an X-ray photo of this object, remember that those colors are assigned to different energy levels. And it's up to the astronomer what his goal and what his purpose is, sharing this information with you, what color he will make those patterns. So you see all those beautiful patterns, from the X-ray telescope or from infrared telescopes, etc. Remember, the only thing that we can see is that narrow band of visible light. Everything else has to be made so we can see it. We can see colors that are put there. But all those colors have a certain reason. And it depends upon the astronomer's purpose in sharing you what color he assigns. So when you see those beautiful pictures, that's not what you're going to see in space. Or space would be really beautiful. They're just energy levels. Okay. I got to share this one with you. I have 36 of these left, and I didn't know how to give them away, so I decided not to. I'm going to give away in a special way. This is an issue of the Earth Scientist. Have you ever seen that? Heard about that organization? It's a cool one. This one back in, when was that? Spring of 2012 came out with this issue, and it's got a set of those cards I'm going to give you. It's got a set of those cards in here. It's also got 4 lessons. I can open this one. I can open this one. Okay. I got the cards. You got a set of cards in there. A set of these kind of cards. And that will be this would be the second set. And they've also got, there's 4 lessons in this thing for students, and they all fit for the Stellar Revolution. So they're pretty decent. I looked on the web. You can go to the Chandra, CHANDRA website. Almost anything your child has to know is on that website. It's all written for students from about 6th grade. For some of the stuff's pretty hard for 6th grade and 7th grade, but the materials are made for students. I know my friend Donnie Young wrote most of it. It's really excellent material. So you can order the book if you go to the Earth Scientist website. They'll have publications, and go to this issue. All you have to do is remember that it's the spring of 2012 issue that you want to get. It's very good, and it's got this set of cards in it. But anyway, it's got a set of the cards in it. Now, because I only had so few, I decided I'm going to give them to you, but there's a hitch. You have to buy my 1995 game, which you can also use to teach your kids, but you get that for free, because I'm not going to sell them to you. These are free. Buy my game. And I want to show you about this for 1 second. It's great for middle school kids, because they take 3 stars of different mass. They work around, they collect mass and time, and they evolve each star from its first little thing in the stellar nursery. It grows and grows and grows, but it gathers mass and time, and there's all kinds of questions they can ask about. They gather mass and time. It's kind of fun. Okay, Chandra helped me create that game. They were my advisors, so it's pretty decent. So what I've done is I've taken that book and I put it in here for free. The book is free, but the game is $19.95. Sorry about that. Okay. Also, I went to the Chandra website and put Chandra educational materials. That'll take you to the right page. As keywords, I didn't want to give you a big URL because they're really long, but I gave it to you. And the lessons from this book are actually in there. You'll have to print them off. The cards are there, but you have to print the cards off. Now, there's another set of these called Cosmic Connection. You can get those cards for free, but I just happen to have enough of these to pass out this summer. That's gone because they don't publish these anymore. But they're available for you to print out, which is probably pretty expensive. But these are printed out really, really nicely. And since I don't want you to walk away without them, can somebody come out and help me a little bit? Just make sure everybody gets one of these. It'll take a second to do that. Just distribute. Just take one. And if you come to my table near the end of the day tomorrow, very end of the session, I might have some left over. I don't know, but I'm going to give the rest of them away. But I'll make sure everybody gets one set. And these sets of cards, it's going to tell you on the Chandra website how to use them, so I'm not going to go through that. Did we get enough? Everybody got one? Hold your hand if you didn't get one. Okay. These have little cards on them, and there's some activities to use with them. That is to put the cards in sequence for a star like our sun, Earth-sized, a sun-sized star, and also one for a very massive star. And then you can also make another one that has the little white dwarf and the giant star from which is feeding material. You can create that one also. But you can have the kids do this. All the activities that you need to know on doing this are on the website. Now, if you want to go so far as getting the second set, a companion set, it's called Cosmic Connection. It's found on the same page as the educational